So in this particular video, I'll cover about the concept of the 0 or 1 knapsack problem using the dynamic programming. So 0 or 1 knapsack problem, to introduce what is actually the problem of the knapsack. That is the knapsack which contains a particular bag, and this bag can hold certain kind of the capacity, and capacity has been given as something like 16 kgs, assume, that is m equal to 16, indicating like the items can be placed in the knapsack not exceeding 16 kgs, and the items are being provided something like your item 2, item 1, item 2, item 3, and so on. And for each kind of the item, the value and as well as the weights are being assigned. Value indicates what is the cost of item 1, cost of item 2, and so on. Weight indicates that is what is the weight of the item 1, and so on. So you should place these kinds of the items into the knapsack such that the capacity should be less than or equal to m. That is the knapsack problem. This kind of the knapsack problem can be solved either by using the greedy approach, that is knapsack problem. Knapsack problem can be obtained with the greedy method, or can also be solved using the dynamic programming. So if you are concerning about the greedy approach, the fractions can also be taken. And if you consider the dynamic program, either you can take that item or drop the item. That is the problem of the knapsack. And since it is a maximization problem, it is a maximization problem. That is, you need to get the maximum profit by considering these kinds of the constraints. So given in your 0 or 1 knapsack problem, given a set of n items, each with a weight wi and the value, that is vi, along with the maximum weight capacity, that is w. Maximize sum of the values of the items in the knapsack so that the sum of the weights is less than or equal to the knapsack capacity. If we exceed this kind of, the limit of the xi, either you can take the item or drop the item. If you are taking, if you are taking the item which has been set as 1, and if you are dropping the item which has been set as 0. So this results to the problem of the knapsack, that is 0 or 1 knapsack problem. That is, find the items x1, x2, x3, etc. such that the profit is maximized by considering the equation, that is sum of i equal pi xi, where i equal to 1 to n, subject to the condition it does not exceed the maximum knapsack capacity, which has been given by wi xi less than or equal to m, where i equal to 1 to n. Subject to the condition, either you can drop the item or pick up the item, which has been given by xi belongs to 0 or 1. That is, you can take the item, you can drop the item or take the item, and where I ranges between 1 to n, the items from 1 to n. So the algorithm related to your 0 or 1 knapsack problem, where m indicates the capacity, weights, it is an array, that is weights, input given weights and values, and as well as n indicates the number of the items. So if you consider the algorithm, that is you're starting from the loop, the I equal to 0 to n, w equal to 0 to m, and you're checking whether I equal to 0 or w equal to 0, and including within your table, that is b of I comma w is equal to 0. So your entire algorithm will be traced with an example. So consider m equal to 5, that is knapsack capacity. M indicates knapsack capacity, and the weights are being provided, that is weight of the first item is equal to 1, the value is 6, weight of the second item is been given, and along with the weights and as well as the profits of the third items are being provided. So based upon this kind of the algorithm which is being provided, that is, you have to solve the problem of 0 or 1 knapsack using the dynamic programming concept. The algorithm is being provided. That is, here when you consider the value of your I to be equal to 0, so take I equal to 0 using this algorithm, and similarly w value will be equal to 0 because it is a nested loop, and then you'll be finding b of 0, 0, which is being provided by that is b of 0 0 will be equal to 0, because b of I comma w is equal to 0 if either I equal to 0 or w equal to 0. In the same fashion, take w equal to 1, w equal to 2, w equal to 3, w equal to 4, and as well as w equal to 5. This indicates the maximum capacity. And you will be including 0, 1, b of 0, 1, where you get the value to be equal to 0, b of 0, 2, and similarly 0, 3, 0, 4, and as well as 0, 5, the values will be equal to 0. That is, either you take the 0 or 1 knapsack problem, or if you take the optimal binary search tree using the dynamic programming concept, or if you take the string editing problem using the dynamic programming, you'll be using about the tabular method. And within the case of here the tabular method, you'll be finding each kind of here the cell, that is what is this b of 0 0, and similarly 0 1, 0 2, 0 3, 0 4, 0 5, and so on, for how many number of items that are being provided. So there will be x field and similarly the y. And here, according to this kind of here this scenario, during your first iteration, you found the values of your the b of 0 0, 0 1. That is considered this is the 0 0 value, 0 1 value, and so on. And to the next step, you need to consider when you take the value of your I is equal to 1 during your next iteration, and take w value is equal to 0, and similarly you'll be finding b of I, that is 1 comma 0. If either I is equal to 0 or j equal to 0, then ultimately it will be equal to 0. And similarly, when you take the value of your w is equal to 1, when you take the w is equal to 1, that is you'll be finding b of 1 comma 1, because I is equal to 1, and similarly w is equal to 1. Then in such cases, you should be checking like if w of this kind of the condition, if weights of I minus 1 is less than or equal to w. What does this mean? By including that kind of the item, if it exceeds this one, then you have to choose the formula b of iw equal to b of I minus 1 w. Else, in such cases, that is if it does not exceed, if it is a true condition, then in such cases b of iw is given as max of values of I minus 1 plus b of I minus 1 w minus weights of I minus 1 comma b of I minus 1 comma w. So here in this case, what about the value of here the w of 0? W of 0 is equal to 0. I'm sorry, w of 0, that is weight of 0, that is 1, is less than or equal to 1. It is the true condition. So if it is a true condition, then you'll be finding the maximum between the items, that is maximum of value of 0 plus b of 0 of 1 minus w of 0 comma b of 0 1. So if you substitute the respective values of 0, that is array 6, that is max of 6 plus b of 0 0 comma b of 0 1, and the max between, you get max between 6 plus 0, that is 6 comma b of 0 1, that will be equal to 0. So where you get the value, that is 6 is been obtained. So in the similar fashion, you'll be finding w equal to 2, that is weight of the second item, and similarly b of 1 comma 2 you'll be finding, and you'll be using the condition, that is this condition is the true condition, then you'll be using this kind of the statement, that is b of iw is equal to max of I minus 1 and so on. So which is equal to max of, and what is the value of the w, that is w equal to 2. So v of 0 plus b of 0 2 minus w of 0 comma b of I minus 1 w, I minus 1, that will be equal to 0, and w value is equal to 2, and you will get the maximum value, that is max of 6, b of 0 equal to 6 plus b of 0 of 2 minus 1 comma b of 0 2, that will be equal to max of 6 comma 0, which will be equal to 0. So in the same fashion, you'll be finding till the value, that is w is equal to 5. So here provided with respective values, and then you need to find, okay, let me take the same values. So okay, this is another example. So far we have found the W value is equal to, or W equal to 2, and the max of 6 comma 0, that will be equal to 6. And in the same fashion, that is find W equal to 3, W equal to 4, and similarly W equal to 5. That is, you will be finding B of 1 comma 3, similarly B of 1 comma 4, and similarly B of 1 comma 5, where you get the B of 0 or B of 1 comma 3. If you substitute the respective values, that is B of 1 3 is been given as 6, B of 1 comma 4 is been given as 6, B of 1 comma 5, which is obtained as the 6 value. So in the same fashion, you'll be finding, that is when the value of your I is equal to 2, and similarly you'll be finding B of 2 comma 0, which is equal to 0, B of 2 comma 1, which is equal to 6, and B of 2 comma 2, which is equal to 10, and B of 2 comma 3, if you substitute the respective values in the the algorithm, that is by replacing the values of your I, j, weight, and similarly the value, that is 6 10. And when you take B of 2 3, the value will be equal to 16, and so on. So I'll give one more example related to the same kind of the example. So what you can do is nothing but at the last, that is at the last, you will be finding, that is B of 3 comma 5, B of 3 comma 5. So what does this indicates? That is, here you are including the weights, that is 0 1 2 3, that is the weight, and the maximum weight, that is 0 1 2 3 4 5. And then you'll be finding what is this B of 0 0 0 1 0 2 0 3 0 4 0 5, and similarly B of 1 0, that is B of 1 0, which is equal to 0, and similarly B of 1 1. So if you look at the B of 1 1, which is equal to 6, B of 1 2, which is equal to 6, 1 3 equal to 6, 1 4, and similarly 1 5. And similarly, if you consider 2 0, so B of 2 0 equal to 6 0, B of 2 2 is equal to 6, B of B of 0 1 equal to 6, and B of 2 2. So B of 2 2, which is equal to 10, and B of 2 3, which is equal to 16, B of 2 4, which is equal to 16, and B of 2 5, which is equal to 16. If you replace the values, and B of 3 0, so B of 3 0 equal to 3 0 equal to 0, 3 1 equal to 6, 3 2 equal to 10, 16, 18, and similarly 22. This is the respective final value that you get. So the maximum profit that you can earn is equal to the last cell that is being present, that is 22. So if you consider the formula B of 3 comma 5, that is max of V of 2 plus B of 2 of 5 minus 3 comma B of 2 comma 5, that is B of 2 5. So here if you consider, if you substitute the values, that is maximum of V of 2, that is equal to 12. So 12 plus 10, after you find B of 2 2, which is equal B of 2 2, which is equal to 10. So 10 comma, and what is the remaining value? That is B of 2 5, that will be equal to, that is 16. So what is the maximum value? That will be equal to 22. And how did you get this kind of the 22? That is 12 plus 10. So look into the 12 plus 10, which has been resulted. If you look at the B of 2 comma 5 3. So B of 2 comma 5 3. So observe the statement, the formula that is related to B of 2 comma 3. That is, when you take the value of your I is equal to 3 and then start W equal to 0 and so on. So this has result to the maximum one. So you should take this kind of the item, that is item 3. And similarly, observe within the case of the B of 2 2. So within the case of the B of 2 2, because B of 2 of 5 minus 3, that is equal to 2. So if you look at B of 2 comma 2, there you have observed the formula, that is B of 2 comma 2, that is max of b of 1 plus b of 1 of 2 minus 2, comma, b of 1, 2. So you can obtain the maximum between, that is 10 plus 0, comma 6, which is equal to 10. And which part has led to the maximum? That is 10. So you should take this kind of here the item. And what is the item? That is when you take the value of your I is equal to 2, you got the maximum value. And similarly, b of 1 of 0 has resulted to this one. That is the maximum value. And further, once again, you have to look into the formula, that is b of 1, 0. And how about the case of b of 1, 0? That is b of 1, 0 is being given with the value to be equal to 0, when the value of your I is equal to 1. Then in such cases, b of 1, 0, that is equal to 0. So you should not take that kind of here the item. So according to this kind of here the problem, that is you have considered item 3, and similarly you have considered the item 2. So x of 3 is being set to 1, and similarly x of 2 is being set to 1, which you get the maximum profit to be equal to 22. This is how we can solve the problem of the knapsack using the dynamic programming. I'll provide one more example related to the 0 or 1 knapsack using the concept. So provided with the values, let me trace back. That is, given the value that is m equal to 5, that indicates the capacity, and the item 1, item 2, item 3, item 4, there are 4 items which are being ranged from, since you need to start from the items, this is your item 1, item 2, item 3, and similarly item 4, and each kind of here the item, the weights and as well as the values are being provided. That is item 1 with the weight to be equal to 2, item 1 with the value to be equal to 3, and so on. So ultimately you'll be using the tabular method using the dynamic programming, and within the case of your the dynamic programming, that is you will be taking about your weights, the items, in vertical fashion, that is 0, 1, 2, 3, 4 for how many number of items that are being present, and the value of your the capacity, that is starting from 0, that is 0 to 5, 0, 1, 2, 3, 4, 5, and then you'll be filling up each kind of here the cell based upon the algorithm related to the knapsack 0 or 1 knapsack using the dynamic programming. So if you consider this one, that is I value is equal to 0, W value is equal to 0, and you'll be finding B of 0, 0, because this condition will be the true condition. If either I equal to 0 or W equal to 0, then you can take like B of 0, 0 is equal to 0. And similarly, you'll be finding this is a nested loop. W value is equal to 1. So B of 0, 1. So B of 0, 1 is equal to 0, because either you take I value equal to 0 or W value equal to 0. Ultimately, B of I comma W will be equal to 0. And similarly, when you take the value of your W is equal to 2, and similarly B of 0, 2 will be equal to 0, and B of 0, 3 will be equal to 0, B of 0, 4, B of 0, 5, and this loop gets incremented by 1. That is I value will be equal to 1 and W value will be equal to 0. You'll be finding B of 1, 0, which is equal to 0, and similarly W value equal to 1, B of 1, 1, which is being given by 0, and so on. So according to this case, that is B of 1, 2, you'll be using the formula, that is B of IW equal to max of values minus 1 plus B of I minus 1, etc. And where you get the maximum value to be equal to 3. And in the same fashion, you'll be finding the other values, that is B of 1, 3, and similarly B of 1, 4, and B of 1, 5, and so on. So this is how you can observe the values which are being generated using the algorithm values. That is, if either of I equal to 0 or W equal to 0, then you'll be using B of I comma W is equal to 0. Similarly, if you take the next value, that is if the weights of I minus 1 is less than or equal to W, then in such cases you will be using B of IW is equal to max of values of I minus 1 plus B of I minus 1, and the other part, that is W minus weights of I minus 1 comma B of I minus 1 comma W. And if the above condition fails, then in such cases you will be using the statement, that is B of IW equal to B of I minus 1 comma W. and this is how the values which are being generated for each kind of your the cell. So once you got this kind of your the value, that is the last value, the last cell, that is b of 4 comma 5, where you get you get the values. So here you can obtain the values to be equal to, that is b of 4 comma 5 is equal to 7. You got this kind of your the value, that is b of 4 comma 7, and trace back which has been led to the minimum, the maximum value, because it is the maximization problem. So if you trace back to the formula which you got, b of 4 comma 5, that is b of 4 comma 5, if you observe the statement, that is b of 4 comma 5, that is equal to b of 4 comma 5 equal to b of 3 5. And similarly, if you consider about b of 3 comma 5, so what values has been led to the b of 3 comma 5, that is if you look at the same example, you got the values which are being added to be equal to item 2 and similarly item 1. How can you obtain these values? I'll explain with an example. Same thing, that is ultimately you have to look into this kind of your the cell with the value to be equal to 7, and how to trace or how to find what items are to be added. So I'll just give an example of how to identify what items are to be added or to be included in the respective values. So here, if you consider this kind of your the value, that is at the last we got the value to be equal to 7, that is b of 4 comma 5 is equal to 7. So if you look at the value, that is when I is equal to 4, and similarly that is you have computed, that is w value is equal to 5, b of 4 comma 5, that is maximum of v of 3 plus b of 3 of 5 minus 5 comma b of 3 and similarly 5. This is how you have computed b of 4 comma 5, and out of which, that is maximum of 6 plus 0 comma 7, that is you got the value to be equal to 7. And which part has led to the maximum value? That is equal to b of 3 comma 5, that is you have b of 3 comma 5. So this includes, that is the next step to be followed is nothing but you have to look into the w value. So when you take about the w value, because here what is the maximum capacity, that is maximum capacity of this knapsack is equal to 5, and what is the value that is being stored in your b of 3 comma 5, which exceeds, and that is the purpose where you should not take that kind of the item into the solution set. And go to the next part, that is because b of 3 comma 5, that is when you take the value of your I equal to 3 and w is equal to 5, that is b of 3 5. And what is the formula to find this kind of the b of 3 comma 5? That is max of v of 2 plus b of 2 of 5 minus 4 comma b of 2 and 5. Replace the same thing using the algorithm. So you get, that is maximum of 5 plus 0 comma 7, which is equal to 7, because you should also not take into the consideration due to the reason like your it has been exceeded this kind of the value. So what is the part that has led to the maximum value? The part that has led to the maximum value is equal to, that is b of 2 5. So when the value of your I is equal to 2 and similarly w value is equal to 5, that is b of 2 and 5. So if you calculate this one, that is you get the maximum of v of 1 plus b of 1 5 minus 3, that will be equal to 2 comma b of 1 and similarly 5, that is you get, that is max of, so max of, that is 4 plus 3, 4 plus 3 comma 3, where you get the value to be equal to 7. So here we are not directly including the value, but we are adding some items here, that is 4 plus 3. then in such cases, you can take this kind of your the item, that is item 2 has to be taken into the consideration, and look into the part which has been led to the maximum value, that is b of 1. That is when you take the value of your I is equal to 1, and similarly b of 1, 5 minus 3, that will be equal to 2. So 5 minus 3, that will be equal to 2. So if you find b of 1 comma 2, which is been given by, that is b of 1 comma 2, maximum of b of 0 plus b of 0 of 2 minus 2 comma b of 0 2, that is equal to max of 3 plus 0 comma 0, which is equal to 3, because it is within the capacity. And you can also check by adding this kind of your item, it does not exceed the maximum capacity of the knapsack. And that is how we have taken this kind of here the solution, that is when you take the item to be equal to 1. And if you look at this kind of here the part, that is b of 0 0, so basically b of 0 0 which is equal to 0, so no items are to be included, 0, that is 0. So items to be added when you consider this kind of here the solution, that is x of 2 should be taken into the solution set, and x of 1 should be taken into the solution set. That is how you got the maximum value of the 0 or 1 knapsack problem. So for this kind of your the 0 or 1 knapsack problem, you got the maximum value to be equal to, that is 7. So 7 has been taken, and this is how we can solve the problem of 0 or 1 knapsack using the dynamic programming, that is tabular method. And in the next video, I'll be providing one more example related to the 0 or 1 knapsack problem, which can be solved. So this is how you can take another example like n equal to 4, and similarly there are 4 items, m equal to 8, and the weight values pairs are being given like 1 3 5 7, and similarly 2 4 7 10, and so on. And similarly if you take the values of your the b of I comma w, which is been set to 0, and you'll be obtaining these kinds of your the values. And after obtaining these kinds of your the values, that is you got the maximum value to be equal to 12. And once you got this kind of your the last cell, that is b of 4 comma 8 with the value to be equal to 12, which indicates that is the maximum cost is equal to 12. That is the maximum profit that you can earn is equal to 12. And what items to be added? Trace back to the respective items, that is x of 4 equal to 1, and similarly x of 1 equal to 1. That is, you need to take into consideration of the 4th item and as well as the 1st item to get the maximum profit to be equal to 12. Here we are not considering the fractional knapsack. Either you can take that kind of your the item or drop that kind of your the item. Then in such cases, these are the two solutions where you can obtain for the case of your the 0 or 1 knapsack problem.